Today we're going to be talking about the equation of a line given a point and a slope. So far, we have done equations of lines when we use the intercepts or we just look at a graph and we can determine the point that the line touches the y-axis or the x-axis, and we can use that equation for the line. But sometimes we're not always going to get a nice point along the y-axis. So in order to determine the equation of that line, we need to have two things. So we would need a slope, and then we need a point. That's it. If you have a point and you have a slope, you can determine the equation of a line. So first example here, find the equation of a line with a slope of 1 over 2 that passes through the point 1 and 5. So this right here is our slope, tells us. The point that we are given is here, 1 and 5. Or our x is 1 and our y is 5. The equation of a line we know is y equals mx plus b. All I'm going to do now is sub in the values that I know into that equation of a line. So if I plug in my values, well, my y value is, I get 5 is equal to, my slope is 1 over 2, and my x is 1. And I don't know my y-intercept. So by plugging in the x and the y value and the slope value, I'm going to get the y-intercept. 5 is equal to 1 over 2 times 1, which is the same as 5 equals 1 over 2 plus b multiplied by 1. This is still 1 over 2. Now I'm going to bring that over. 5 minus 1 over 2 is equal to our b, or our y-intercept. We have some subtracting of fractions. Remember that a whole number can always be written as over 1. The first thing I would need to do is to have the denominators the same. So I would multiply the first fraction here by a factor of 2 so that my denominators are the same. So I would get 10 over 2 minus 1 over 2 is equal to b. Well, 10 minus 1 is 9 over 2 is our b value. So that means that the equation of this line, y is equal to 1 over 2x plus 9 over 2. Graphing will hopefully shed some light on what this actually means. All this means is that the y-intercept is 9 over 2. Well, 9 divided by 2 is 4.5. So it's going to touch the y-axis at 4.5. But we don't have that clearly labeled here, so it'd be kind of tricky just to guess where it would go. Sometimes it's not always going to be directly the half. But we do have a point. We have a point of 1 and 5, and we have our slope. So the point of 1 and 5 can be plotted. 1, 5 is going to be here. And our slope of 1 over 2, which is rise over run, if I go up 1 over 2, I get that point there. And I follow that pattern along, and I create a line like that. So we can see that where the line touches the y-axis is at 4.5, or is right about there, right? So that's all this means here. So the y value, or the y-intercept, is 9 over 2. And that's how we would express it in this equation. Second example, find the equation of a line with a slope of 4 passing through the point of -2 and 1. Well, our slope is here. Our point, we have an x and a y. Okay, let's plug it into the equation. So we have y equals 4x plus b. We're trying to find that y-intercept. my y value is 1, is equal to 4 multiplied by -2 plus b. 1 equals -8 plus b, or 1 plus 8 is equal to b. I just simply brought this -8 over, it becomes +8. So now I'm left with 9 is equal to b. So I have my y-intercept. Now if I rewrite the equation, y equals 4x plus 9. Now the reason I rewrite the equation, only keeping the slope and only keeping the line, is because not every single point is going to land on that line, right? So if we just kind of scroll up for a moment, and we have the line that's given to us here. Let me use a radical color here. Sure. If I plot this point, 4 and 4, we can clearly see that this point does not touch this line. However, what happens when we don't have this line to see and we don't have a grid to use? Well, we would be given a point other than this, and we would try to plug it into here. And if the right side equaled the left side, then that would mean that the point is touching the line, right? So the big takeaway from this is all we need to do right now is find our y-intercept, which we do, and then rewrite the equation of a line with our slope and our y-intercept. So find the equation of a line with a slope of 5 over 6 through, or passing through the points 6 and 5. So my equation of the line, y equals mx plus b. What do I know? Y equals 5 over 6x plus b. We're trying to find our b. Plugging in our values that we know, well, my y value is 5, is equal to 5 over 6 multiplied, x value is 6, plus b. Now I can go ahead and try to solve for that b value. Well, these 6's over here, something divided by 6 and multiplied by 6, those cancel out. So I'm left with 5 is equal to 5 plus b, which means that 5 minus 5 equals b, which is 0. So the y-intercept is 0. So the equation would be, therefore, y is equal to 5 over 6 x. We don't need to write in the y-intercept because it is 0. We can just leave it as y equals 5 over 6x. All right, word problem. Sophia knows that it costs $25 to take a taxi to work, which is 10 kilometers from her home. She forgets what the fixed cost is, but remembers that the variable cost is $2 per kilometer. Find the fixed cost and write the equation that relates the cost in dollars of a trip to the distance in kilometers. Okay, there's a lot going on here. What are some things that we can take away simply by reading this whole thing? Well, I'm going to take away that it costs 25 bucks to go 10 kilometers, so it costs $25 to take a taxi to work, which is 10 kilometers away. $25 for 10K. Okay, that's one point. Another point we can take from this, the variable cost is $2 per kilometer. Well, we know that as our slope. Okay, so we have a slope. Find the fixed cost and write the equation as it relates the cost in dollars of a trip to the distance in kilometers. Well, the cost is going to depend on how far you travel. So the cost is actually the y coordinate, or the dependent variable, and the distance is the independent, or is our x variable. So I'm just going to simply say let x be distance, let y be cost. So if I was to write this as an equation, it would be y equals, well, no, my rate is 2x plus b. Okay, that's not really a full equation though. We're still missing the x, we're still missing a y, and we're certainly missing the b, or the y-intercept. Can we take the information that we have from here, plug it into this equation, and find the equation of a line? Well, to do that, we would need a point, right? If you remember, what are the two things we need? We need a slope and we need a point, an x and a y. Do we have an x and a y point? We actually do. $25 for 10 kilometers. So it cost, at 10 kilometers, it's going to cost you 25 bucks. So if I was to plot that, when x is 10, y is 25. So x is distance, y is cost. So I'm going to plug that in. What's my y value? Is 25 equals 2. My x is 10 plus b, my y-intercept, which in this case, 25 equals 20 plus b. So then my b value, or my y-intercept, is 5. B is equal to 5. Right, when you think about it, that kind of makes sense. It cost 25 bucks to go 10 kilometers. She remembers that it's $2 per kilometer. Okay, so $2 per kilometer means it costs you 20 bucks just traveling, but we forget what the fixed cost is. Well, if it costs you 25 total minus 25, minus 20, it's going to give you 5 bucks. So just to sit in the cab costs $5 before you even start moving. So that means is that the equation is y equals 2x plus 5. That is our equation. Second step, we're going to graph this. Graph the linear relation. Well, where can I start from? Well, I can start from my y-intercept, which is 5, which is right here. There, roughly 5. My slope is 2, so I go up 2 over 1, or 2 over 1. And I simply have these points very roughly along this graph, or along the line that I've created, just like that. Y equals 2x plus 5. That's what that looks like. All right, part C. If Sophia is going to the mall after work, which is 12 kilometers away, how much is the trip going to cost? Okay, remember our equation. Y equals 2x plus 5. The new piece of information is 12. Does 12 go in for the x, or does 12 go in for the y? Well, x is distance. We want to know how much it's going to be. So y equals 2 times 12 plus 5, right? The rate of change multiplied by the distance traveled plus your initial fare, or your flat rate, which is 5 bucks. You're going to get y equals 24 plus 5. Y equals 29. So therefore, it will cost $29 to go to the mall. Okay, we're now going to find the equation of a line parallel or perpendicular to given lines. So, yeah, I'll keep it blue. Find the equation of a line parallel to, should I do this? Parallel to this line here, y equals negative x plus 12, and that passes through the point 2 and 5. Okay, so parallel we know means the same. Same slope, right? So therefore the slope of this line is going to be negative 1. So in my equation, y equals negative x plus b. Well, now I need to plug in my values of my x and my y that are given. So now I need to plug in my x and my y values. So negative 5 equals negative 1 multiplied by, well, in this case, the x is 2, plus b, right? Remember, this is a new line. This is not the same as the one that's highlighted. So negative 5 is equal to negative 2 plus b, which would then give me negative 5 plus 2, which would give me negative 3 is equal to b. So therefore, the new line is y equals negative x, because that's the same from up here, minus 3, right? It is parallel to the line, and it passes through the point 2 and negative 5. If you remember what I talked about earlier on, about how visually we can see a point that is clearly not on the line drawn, this is kind of proving that without using a graph, right? So this point does not touch this line, but this point does touch this line. Let's try another example here. Find the equation of a line perpendicular to y equals 4x plus 5 that passes through the origin. Okay, before we do anything, the origin is 0 and 0. I don't want to forget that. The equation of a line perpendicular. Okay, so we have perpendicular. This is kind of a key piece here. Perpendicular means that this is the negative reciprocal. So if the slope is 4, the negative reciprocal, or the perpendicular slope, and we write a perpendicular slope almost like an upside down T, and we can see how this kind of creates like a perpendicular line. The perpendicular slope is then negative 1 over 4. All right, so we have our slope, and we have the point passes through the origin. So y equals negative 1 over 4x plus b. Well, where's the y-intercept? We don't have one. Well, it's at 0. So the equation of this line is negative 1 over 4x, passing through the origin, right? Last quick example here, thinking style question. Okay, so find the equation of a line perpendicular to 3x minus 5y plus 10 is equal to 0, okay, with the same x-intercept as the line y equals 3 over 5x minus 6. Okay, there's a lot going on here. So I'm going to chunk this up. First thing we need to do, find the equation of a line perpendicular to this line here with the same x-intercept, as the line y equals 3 over 5x minus 6. Okay, so first thing I'm going to do, this is our first thing. This can be our second thing. First, find slope. Well, the line I have is 3x minus 5y plus 10 equals 0. Well, I'm looking for the form y equals mx plus b, so I'm going to rewrite this. 3x plus 10 equals 5y, right? I just took this negative 5y, brought it over, made it start to isolate my variable for y. Divide everything by a factor of 5, so then 3 over 5x plus 2 equals y. So I'm looking for the slope. So the piece of information I want from this is my slope is 3 over 5. That is the piece of information I need from the line in blue. Second thing we got to do is find the x-intercept of that line. So finding the x-intercept of this line. Okay, so when we find the x-intercept, we do something to the y value. So we would set y to 0. Set y equal to 0. Right? There's no y value, it's touching the x-axis. So that would be 0 is equal to 3 over 5x minus 6. Start to isolate for the variable x. 6 equals 3 over 5x. Multiply both sides by 5. 30 equals 3x. Now I divide by 3. So the x-intercept of this line is 10 and 0. So I have to do one final thing. I now need to find the equation of a line that is perpendicular with the same x-intercept. So I realize now, looking over here, I didn't go one more step. If you picked up on that, great. I need to find something that's perpendicular. Well, this step just simply found the slope of this line. But we know that the perpendicular slope is the negative reciprocal. So the slope that we're actually trying to use is the negative reciprocal, which would be negative 5 over 3. This is the correct slope that we need to use. So our slope, I'll be consistent with the colors here. No, actually that was good. My slope is negative 5 over 3. The point that I have, the x-intercept is 10 and 0. So now I can plug in all those values, right? I have my slope and I have my point, just so happens to be the x-intercept, into the equation. Y equals negative 5 over 3x plus b. Well, my y value is 0. Negative 5 over 3 times 10, that's my x value, is plus b. So I now have 0 is equal to negative 50 over 3 plus b. So then 50 over 3 is equal to b. So our y-intercept is 50 over 3, which means that the equation of this line, y equals negative 5 over 3x plus 50 over 3. Okay? So the big takeaways, if I kind of go through this one more time, the big takeaways here, we need a slope and a point in order to find the equation of the line. If we have a slope and we have a point, we simply plug them into the equation of a line. We get our y-intercept, and then we have our new equation of a line. When looking at lines that are parallel or perpendicular, we just need to realize that parallel means the same, so I'm taking the same slope as this line, whereas perpendicular means the negative reciprocal. I'm taking the negative reciprocal of this, and then identifying what point we have to plug into the equation. And that thinking question here is a really kind of summation of everything that we've done so far. The equation of a line, we found the perpendicular slope by first finding the slope and then finding the perpendicular slope. We found the x-intercept of this line, and then we found the equation of our new line using our slope and